Okay, let's do practice it exercise. That's right, exercise 4.1, fraction sum. We're actually going to have to write a method. We're going to write a method called fraction sum that accepts an integer parameter n and returns as a double the sum of the first n terms of the sequence. Whoa, that's a lot of information. Let's just write the header first, right? It's called fraction sum. There's a parameter n that's an integer, and it's going to return as a double the sum. Okay, that's enough information. Okay, so we'd say public, static, not void, because it's going to return something. What did we say it was going to return? What type? A double, and it was going to be called fraction sum. Fraction sum, camel case, and a parameter, an integer, n. Int n. Okay. I'm going to add a couple comments just so we're clear on what we're going to be coding here. And I can just refer to that again and again. Oops, if I can type. Okay, so we're going to have a parameter, and we're going to have a return value. Let's see the details there. The parameter is n for n terms in the sequence. Oops. And the return is a double. It's the sum of first n terms. Okay. How do we do it? Let's go back and look at the description again. There's this weird math symbol here. You might not have seen anything like that yet, but here's an example. In other words, the method should generate the following sequence: 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus ... So if n was 1, it would just return 1. But if n is 2, it's going to say 1, but then it's going to add 1/2 to it. Seems like we're going to be repeating things, so we're going to need a loop. That's right. So if the number n is 5, this sum of the first 5 terms in the sequence is what we would get. But let's write the loop header first. Say for int, we want a counter, let's call it I. We can start at a value of 1, and then we want to go continue as long as I is less than or equal to n. Well, if we want to have n terms, we'll count from 1 to n. If it's 5, 1, 2, 3, 4, 5. So we'll count until we get less than or equal to. As long as we're less than or equal to 5. Then our increment is going to be by 1s, so we'll do I++. Great. Now we can figure out what's going on in there. Oh, and since we're going to be returning something, we need something at the end. That's right, the return statement. And we're going to return some variable, right? Which we haven't even created yet. Think about it this way. If we go with the example of 3, the first time through the loop, we're going to say, well, we have 1. The second time through the loop, we're going to say, well, the current term is 1/2, but we have to add it to our 1. So we have to add that in. And then we'll have a total, whatever 1 plus 1/2 is. Yes, 1.5. And then the third time through the loop, we'll have to figure out what 1/3 is and add it to that thing. Remember what it was? 1.5. So 1.5 plus 1/3, 1 point whatever. And then the next time through the loop, we'll get 1/4 and add it to that thing that we got to remember from the previous time. If we need to remember something, we need a variable. That's right. And the variable has to exist before the loop starts. Should it be an int or a double? If we're going to keep track of 1 plus 1.5 plus 1/3, and so on, we're going to need decimals, so we need a double. And if we're adding things in again and again, we could call that a sum. Okay, so when we get into the loop, we have to take the sum and add in that fraction, 1 divided by 2, divided by 3, divided by 4. What is the thing that's counting from 2 to 3 to 4? It's our counter variable, I. So far, so good? Okay, but this adds those two things together, but it doesn't then do anything with it. We need to stick it back into the variable, so we could say sum equals sum plus 1 divided by I. Or if we want to do the shortcut, plus equals, right? Okay, now once we're done, we'll return sum. Now there are a few problems here that we still have to deal with. Actually, there's a couple problems we still have to deal with. But let's run it, and let's see what happens. Whoa, your code did not compile. Variable sum might not have been initialized. Did we give it an initial value? No, we did not. So before we try to add something into sum, it has to have a beginning value to start with. Well, the first time through, we want to add in 1, and the result has to be 1. So initially in sum, what value should be in there that if we add 1 to it, we get 1? Well, if it's 0 at the start, we can add in 1, and we'll get 1. And then the next time through, that'll have a value of 1, and we'll add in 1 divided by 2. And then it'll be 1.5. So we want to give it an initial value of nothing. It's like if you go to the store and you go to the cash register and you buy a bunch of stuff, the first time you buy something, you just add the first price in, and that's how much it costs. But then we got to add in another price and another price and another price. So we want to have a running total of how much we've spent, or in this case, how much we've added together. Now let's run it. Maybe there won't be any errors syntactically. Okay, it ran, and it passed 1 of 3 tests. Let's see which ones it passed and which ones it didn't. If the sum was 1, our result was 1.0. That's correct. But if we tried to add 2 values in the sequence together, we should have gotten a 1.5, but instead we got a 1.0. If it was 15, we should have gotten a 3.31 blah, 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 but instead we got 1.0. It seems that after the first one, we're not adding anything in. If we're not adding anything in, we must be adding in 0. Why is 1 divided by 2 0? Why is 1 divided by 3 0? Why are all these divisions 0? Think of the types. This is an integer. I is an integer. If we divide an integer by an integer, we get an integer. 1/2 should be a fraction with decimals. So we're going to need to introduce a double in here somewhere. We can either cast it to a double by saying double like that, or there's a nice little shortcut. We could just make this one a 1.0. Now it's dividing not an integer 1, but a double 1 divided by an integer. And a double divided by an integer, remember the werewolves and zombies? This becomes a double. So now we're adding in decimals, 1 plus 0.5, plus 0.33333, and so on. Now let's run it. Oops. We messed something up there somewhere. We're getting decimals, just not the right ones. What could possibly go wrong here now? Well, let's look at what the output is giving us. With the test of 1, our return is 2.28. With the test of 2, our return is 2.28. With the test of 15, our return is 2.28. So we're getting the same result every time. Even though n is changing, why is the loop not changing? Oh my gosh, we didn't even put in n, did we? Where's n supposed to be? It's supposed to be right here. So that the endpoint of the number of times the loop repeats is based on how many it asks for. If it's 15, this will count from 1 to 15. Now let's try it. Boom. Passed, passed, passed.